Okay, in this question, we are asked to find the early start, early finish, late start, and late finish of every activity. As we learned in previous also videos, in the lesson videos, that we do this by doing a forward pass. Pass means a series of calculation where we go from left to right, and doing that we find the early start, early finish of every activity, and then to find the latest start, late finish, we do calculation backward, and we call that the backward pass. Now, what's our starting point? You see, this is a PND that we have. In order to note down our four values for every activity, let me divide, for example, activity A into three. Three areas, and in the middle I will have the activity number and its duration, 5, which is given to us. And then I will write down here the early start, okay, and here the early finish, and then we have the late start and the late finish. This will organize our calculations well, okay. So let's divide every node similarly, so that we make our calculations clear. And let me just clean up what I have here so that you don't get confused when we start typing the answers. Okay, how do we start a forward pass? You remember we set the the early start of the starting node to be equal to 0. Okay, so okay, sorry, I just forgot to do that for you. In the red, I'm adding up the duration that's given for every activity. That's given, you don't have to find it yourself, right? So everything is in red, it's given, and I'm putting it in red so that you distinguish it from the values that we are calculating. So here we go. A is 5, B is 6, C is 4. These are, I'm getting them from the table that was given to us. D is 3 weeks, E is 1 week, F is 4 weeks, G is 14 weeks, G is 12 weeks, and I is 2 weeks. Okay. So now we start by setting the early start of the starting node, whether it's virtual or not. Okay, so this is our starting node. I will set its starting ES to be equal to 0, then the EF, it's equal to ES plus the duration, so that's 0. Now I will move from S to A, and the early start for A will be equal to the early finish of the predecessor, right? So 0 here, and the early finish will be 5. Then I go to 5, which also has an immediate predecessor, the starting node, so that's why its early start will be 0. Then I add this to 6, and it has a early finish of 6. Now I need to move from A to C, right? From A to C. So the early start, what's the earliest time activity C can start? Of course, it has to wait for A, which is its immediate predecessor, to be completed, which happens on week 5. So this will be the early start of activity C, and it will have an EF equal to 9, right? 5 plus 4 is 9. The same for D, it will have the same early start as C, because it has also the same predecessor A. So 5 here plus 3, 8. Then for activity E, I will have 5 plus 1, 6. Then we go to activity F, right? F has only one immediate predecessor, so it has an early start equal to the early finish of E. So here we go 6 plus 4, 10. Then we go to G. G also has one immediate predecessor, which is F. So its early start will be equal to the early finish of F, which is 10. 10 plus 14, that's 24. Then we go to H. All right, H can be a little bit, it's a little bit harder than the others, or it's not as straightforward as the other, because it has two immediate predecessors. It has B and it has C. So H should wait for both these to be completed before it can start, which means what? Which means that the early start of H cannot be at week 6, right? Because C is not done by that time. So it has to wait for week 9 for C to be completed, and at that time, of course, B is also completed, which means H can start. So the early start is 9 here, all right? So 9 plus 12, that's 21. And also for I has two immediate predecessors. It has G and it has H, and it has to wait for both of these to be completed. So which means that it has to wait until week 24. So that's 24 here, plus 2, that's 26. Good. So now what we did, we just found, in fact, the project duration, 26, which we did it before by finding the critical path. Anyway, that was not our objective here. What we want to do is to find these 4 values for every activity. Now we want to do the backward path. So meaning that we start our calculation from that final activity I. And what do? We set the latest finish of that activity I to be equal to its early finish of 26. So here we go, 26 minus 2, that's 24. Okay, then we go from I backward to H. I has a latest start of 24, so the latest finish of H will be the same, 24, and 24 minus 12, that's 12. Now we go to G. It will also have a latest finish of 24, which is the latest start of I, so 24, and then I'm moving backwards, so my calculations are backwards, so 24 minus 14, that's 10 in here. Okay, now I will move backward from G to F, and the latest finish of F will be the latest start of G, which is equal to 10. 10 minus 4, that's 6. Then we move to from F to E. Okay, from F to E, the latest start of F is equal to 6, which means this will be the latest finish of activity E. Here we go. Okay, then 6 minus 1, so that will be 5. Now we go to activity D, meaning that I'm doing that. Now calculation from here to there. Now, the latest start of G is 10, which will give it to as a latest finish for D. Okay, I'm looking here. So this will be 10, and 10 minus 3, that's 7. Now, if I want to go and find the latest values for C, so I have C is only a predecessor for H, so it has the latest finish of it comes from the latest start of H, so that will be 12 here. 12 minus 4, 8. And then for activity B, also it is the immediate predecessor only for H, so here we go, we're doing that. So that's 12 here will be the latest finish for B, and then the latest start of B is 12 minus 6, that's 6. For activity A, here you have to pay attention. This is the hardest of all of these. Activity A has or it's a predecessor of 3 activities, right? It is the predecessor of C, the predecessor of D and E. All right. Now you can notice that each one of these has different latest start. Activity C has a latest start of 8. This has 7, and this one has 5. So for example, can I give the latest start of A to be equal to 8? Okay, which is this one. I cannot. Why? Because if I allow A to finish at its latest on week 8, then activity E cannot start on week 5 as noted here. See? So that's why the latest finish of A will be the minimum of all the 3 values 5, 7, and 8. So here we go, it's 5, and 5 minus 5, that's 0. Now, activity, the starting activity is a predecessor for these two, which means also the same logic. Its latest finish will be the minimum of these two values, this one and this one. So this will be 0, and 0 minus 0 is 0. And as I explained to you earlier in the lessons videos, that you should expect to have all zeros for the virtual activities, because it's virtual, it's not a real activity. Okay, so now we found all these 4 values for each activity, which allows us to do next. What we're going to do next is to find the slack of every activity. So let's go ahead.